In this video, we're going to talk about multiplication rules of probability. This is going to be used when we're finding the probability of events occurring in a sequence. So this is going to be for occurring in a sequence. Previously, we talked about events that occurred at the same time, and we used the addition rule. This time, we're going to talk about events occurring in a sequence. And one thing that we need to discuss is independent events. Independent events are events where the probability of the first does not affect, let's redo that, the probability of the second. In other words, it doesn't change what happens to the different ones. Some examples are the probability of drawing a card, then rolling a die, and we want to know the probability of each one of those happening. It doesn't affect that item. Just like previously, the probability of drawing two cards, but we replace it. Because we replaced it, it does not change the outcome of what happens on the second card. The probability of that second card stays the exact same. And therefore, these are independent events. So when events are independent, the probability of both occurring is the probability, and we're having, okay, so the probability A and B is equal to the probability of A times the probability of B. In the previous video, we were talking about the probability that A or B would occur, and we added. Here we're talking about the probability that A and B occur, and we're going to multiply. So that's going to be the major difference here. Also, that we're wanting this one to occur, then this one, or vice versa. So let's look at an example. 3 cards are drawn from a deck with replacement. Therefore, we're putting them back each time. Find the probability the first is a red card, the second is a king, and the third is a diamond. Okay, so that's the probability that we want a red, then we want a king, and we want a diamond. Since I replaced it each time, the probabilities aren't going to change. That's going to be the probability of a red times the probability of a king times the probability of a diamond. Let's think about it. How many red cards are there? Well, there's either black or red, so that's half of them. So there's 26 out of 52. How many kings are there? There's 4 kings out of 52. Now remember, I've drawn a red card, but I have put it back. Therefore, I still have 52 cards to draw from, and I can still draw all 4 kings. Now, I've put the king back, I've put the red card back also, so I still have 52 cards to draw from on my third draw. And how many diamonds are there? Well, there's 13 diamonds. So when we multiply this, 26 times 4 times 13, I get 1,352, and where I multiply 52 times 52 times 52, I get 140,608. Now those are some large numbers to try to simplify. If I wanted to, I could simplify those. And if I did, I would get 1 out of 104. The easiest thing with this large of numbers is to put it into 3 decimals, which is going to be 0.010. Because remember, again, we are going to round to 3 decimal places when we're looking at this. So the probability where I draw 3 cards of getting a red, a king, and a diamond is going to be about 1% if I change it into percentages, but probability-wise it's 0.10, or 1 out of 104 cards. Not a large probability there, but it can happen. So we've talked about independent events, but what are dependent events? These are events in which the probability of the first changes the probability of the second. This is examples would be drawing a card from a deck of cards, and you want to draw a second card, but you didn't put the first card back. So now you only have 51 cards to draw from. So it changed the probability of the second event happening because I only have 51 cards to draw from. And when we're looking at this for dependent events, most of the time we also discuss conditional probability. Conditional probability is the probability that an event B occurs after an event A has already occurred. Okay. So getting a king on the second draw, given that an ace was drawn on the first draw. So let me write that out. So this is something like we're getting a king on the second draw given that an ace was drawn on the first draw. Okay. Well, the problem with this is that what happens to our probability? And what happens is it changes the way it looks. We have this item, let me go back to the previous. When we're talking about this conditional probability, this is the probability of getting event B, and this line right here refers to the given. So event B given that A has already occurred. And that is the notation for conditional probability. And it's really important that we look at this because when we're talking about dependent events, the probability that both of them occur, so the probability that A and B occur, is equal to the probability of A times the probability of B given that A has already occurred. Because we don't want to just say the probability of B, because we've changed its probability drastically because we've already gotten something on the first time, the first chance. We've already gotten A. So it changes what's going to happen with our probabilities there. Okay, let's look at an example and maybe that'll help us. What is the probability of drawing a king, then an ace, from a deck of cards without replacement? Okay, so we want to know, we want to draw a king first, then an ace. So drawing a king first, that's no problem. The probability of a king is our 4 out of 52. We know that, no problem. Since we don't replace that king, the probability of drawing an ace changes. So now we have the probability of an ace given that we already drew a king. We have a king sitting out of the deck. We started with 52 cards. I drew one of them. So now I'm down to 51 cards because I did not put that king back. How many aces do I have? Well, I know that I drew a king because that's what this is telling me. I've already drawn a king. So all 4 of my aces are still available. So the probability of drawing an ace, given that I already drew a king, is 4 out of 51. Notice my denominator goes down because I'm not putting that king back. And that's the biggest thing that changes for us. So we have the probability of a king and an ace without replacement is now going to be the, let me write this out figuratively, the probability of a king times the probability of an ace given we drew a king. So that's going to be 4 out of 52 times 4 out of 51. And so that's going to give us 16 over 2652. And when I divide that, I get 0.06, I'm sorry, 0.006 as my probability. Very small probability again, but it's one of those, I have to look at this item. I didn't simplify, or I'm sorry, I did not replace that king, so I have to reduce how many cards I am choosing from now. Conditional probability can also be written looking like this. Probability of B given that A has already occurred is equal to the probability of A and B, in other words, both of the events happening, divided by the probability of A. So it's the probability of both events happening divided by the probability that the first event happened. And that's just another way of rewriting it. It's the same equation that we started with earlier, where we were looking at the probability of A and B happening. We just solved it for the probability of B given that A has already occurred. Okay, probabilities for at least one, or at least. Anytime that you're doing at least, and you see the word at least, I want at least 3 to happen, I want at least 4 to happen, things like this, we're going to use multiplication rules and complementary event rules. Which means we're going to be using the P of E, the P of E bar, the fact that the P of E bar is equal to 1 minus the probability of E. Recall these types of things. We're going to be using those for anything that we want for at least, and even at most for some of the respect. So let's look at an example. Here we have the American Automobile Association reports that of the fatal car and truck accidents, 54% are caused by car driver error. If 3 cars are chosen at random, find the probability that Part A asks us all are caused by car driver error. So I'm going to choose 3 accidents. So I've got 3 different accidents, and they're all going to be car driver error. Well, if they're all car driver error, the probability of car driver error, probability of E, is going to be 0.54, my 54%. So if I want all of them to be that, I'm going to put in here 0.54 times 0.54 times 0.54. And that will give me that the probability that all are car driver error is going to be 0.157. So the probability that all 3 accidents are caused by car driver error is 0.157. And I wrote it out like this because anytime that we're answering questions such as this, we want to make sure that we write it out and explain ourselves. Just the number doesn't really give us the answer. We need to be able to write a sentence, complete it, things of that nature. Let's look at Part B. Part B gives us the same scenario, that we're still looking at 54% are caused by car driver error. We're still going to choose 3 accidents, but this time none of the accidents are caused by car driver error. Okay, so this is the total opposite of what we just looked at. Well, remember that if event E was car driver error and it was 0.54, the very opposite of that is the probability of E bar, the complement. Well, to find that, I'm going to do 1 minus 0.54. So the complement of that is going to be 0.46. So the probability that it's not caused by driver error, just one accident, is 0.46. So the probability that none are caused by driver error is going to be 0.46 times 0.46 times 0.46, because we're talking about all three of them, which is going to give me 0.097. And again, we would answer that in a sentence. The probability that none of the accidents are caused by driver error is 0.097. Okay, so we've done the all, we've done the none. Now we want to look at least one is caused by driver error. So at least one. At least one means that it can be one accident, or it can be two accidents, or it can be three accidents that are caused by driver error. I could do something along the lines of one accident being caused by driver error and the others being not caused by driver error. So one accident is caused by driver error. That would be caused by driver error and the others not caused by driver error. Two accidents would also be included in this. So that would be this. Two of them are caused by driver error and the third one's not. Or it could mean three accidents are caused by driver error. So that would be 0.54 times 0.54 times 0.54. And if I want one accident or two accidents or three accidents, that would mean I would add all of these up. Now for something this small, that would be okay, but notice the one that is not included. Not included right now is the probability that zero or none of the accidents are caused by driver error. So what we can do is the probability of at least one being caused by driver error is equal to the 1 minus the probability of none of them being caused by driver error. Because the only way that we're going to discuss at least one, the opposite of that is none of them being caused by driver error. And so if we want to do an opposite, remember, we can do a 1 minus. Well, the probability that none of them are caused by driver error was our 0.46 times 0.46 times 0.46, which we found in the previous part of the problem, which was 0.097. If I take that from 1, that's going to be 0.903. So the probability that at least one accident is caused by driver error is going to be 0.903. Again, I could do the previous way of trying to add these things up. It doesn't come out the same because we don't know exactly what's happening to some of these, and we also have to include, is it the first accident or is it the second accident? And so there's different ways of including it. So this way right here, not real smart, not very wise. We need to be able to figure out and do the complement of something. Okay? Because like I said, we would have to figure out, was it the first accident, or was it the second accident, or was it the third accident that was the one accident, and add all of those up. That looks a lot more complicated than if we can do the not included part. Anytime that it's something of an at least one, make sure that you're going to do the 1 minus. And that's what we're looking for here. Okay? If you have questions, come by and see me.